Welcome to part 3 on the float data type. The float wrapper class in Java has a couple of constant values. We are going to look at the infinity and NaN constants in this lesson. Here I have a small application in which we will continue exploring the primitive float, the data type in Java. So I'm just going to run this application. So I'm going to say Java. So I'm going to run it with the Java command that you can run in memory, compile and run in memory. Okay, there I've run. So here's my application. So to infinity and beyond. The float data type defines two infinities, the positive infinity and the negative infinity. Results of some of the operations on the float are not defined. For example, dividing a 0.0 float by 0.0 float type is indeterminate. You can see my previous lesson on this, where I deal with zeros in floats. Indeterminate results are represented by a special value of the float data type called the NaN, not a number, and note the small a surrounded by two capital N's. And you can see previous lesson on this as well. Java has a float class, note the upper F in the float, which defines three constants that represent positive infinity, negative infinity, and NaN are the float data type. So we're going to look at these constants. Now, I also introduced, using the text block introduced in Java 15, to format this output. And the tip here is when you use this, it's easier to format your output if you activate your tabs and your spaces and all that when you programming, writing your source code using the text block tabs. I'm just going to show you what I mean there. So in my editor, now depending on your editor, you'll have to see how yours gets set up. I can go to my preferences, I can go to plugins and activate draw spaces, and then I can see all the tabs and so on, and I can align my text blocks nicely. I can without it makes it a bit difficult. You're guessing. Okay, I can see I've got two tabs and line carriage there, or enter, what you want to call it, and so on. And I can see if there are any spaces. Yeah, I've got a couple of spaces which is the same length as a tab, and so on. So just going back to the code. Okay, in the code below, I use the float class to display positive, negative, infinity, and NaN to the console. So the float.positive infinity will output infinity. The float.negative infinity will output negative infinity. And if you look at that, what I'm outputting is this here. You'll see if I go here, I'm outputting a float, this one here, float dot positive infinity, and I'm just showing it in my application what I called. I'm just printing it out, so there's the explanation. I've used System.out.println and so on, and I called float constant positive underscore infinity. So the rest will work the same way here. Take note of the small a in the NaN. In this case, float.NaN will output a NaN, as you can see over here. And below, I'm going to declare float variables, constant variables, to do maths here. So, and here are the results. So I said float f1 is equal to 55.0f, and I'm adding the float positive infinity to it, and it gives me a positive infinity. The float plus a negative infinity will output a negative infinity. Minusing an infinity from a real number results in infinity. So yeah, what I'm doing is I'm adding a float to a positive infinity and the same value float to a negative infinity, and again I get a negative and a positive infinity. And if you look at these two, I will be over here just to verify. I'm minusing a positive infinity and minusing a negative infinity. Okay, so as you can see here, I'm minusing a negative infinity, so I've actually got two negative here. It's minus minus. It's giving me a positive here, infinity. It is right. You recall negative and negative makes it a positive. And dividing a real number by infinity results in 0. So here I'm dividing a float with negative infinity and a float with positive infinity, which is giving me a negative 0 and a positive 0. So dividing a number by 0 gives you 0. And then I'm multiplying a real number to infinity. So I've got a positive, multiplying a float by positive infinity and a float by negative infinity, vice versa, and I'm getting a negative and a positive infinity here. The float class has an instance of static methods to test the infinity, namely a boolean is infinite, which is a instance method, and here you can see the static method. The static keyword in front of boolean is infinite, and you pass it a float. And here I'm using it, so I'm saying float positive infinity, and I'm saying is infinite. So I'm checking if the float f9, which is this one here, I'm saying float f9 is infinite, and float f9 is positive infinity, so it's giving me, and I'm using an instant method here, and it's giving me true. And here I'm doing the same with f10, which is float negative, so both positive and negative infinity results in true. And here I'm taking this float 111.33f, and I'm passing it in the static method. You see that f11, I'm passing it there, f11, and it's giving me a false, which is correct, since 111.33 is not infinite, is not infinite, it's a finite value. Okay, doing maths with Float.NaN results in a NaN. So here I've got f11, which is that value here, and I'm adding a Float.NaN to it, and it's giving me not a number. So when I do maths with a not a number, it's going to result in a not a number. Okay, and just like the infinite, the float class, which is the wrapper class, has instant and static method for testing for not a numbers, and they are the instant method boolean is NaN, and the static method, which takes a float boolean is NaN, and it takes a perimeter float. And we'll still come to methods later on in the course, but take note of this. And I'm taking float f12, which is a positive infinity, and I'm using its instant method of f12 the dot operator is NaN, and it's giving me false because it's positive infinity, and positive infinity is not not a NaN, it's an infinity number, so it's false. And I'm using the same, I'm using another instant method with the NaN this time, and it's returning a true. And I'm using that f14 is 11.33 of type float literal, and I'm asking it, is it a NaN? But this time I'm passing the perimeter, as you can see over there, f14, so I'm using its static method, and that's usually how you would use a static method. You pass the instant to it, and then it's resulting in a false. We've come to the end of this lesson. Here we travel to infinity and beyond using Java's float constant values. I hope you enjoyed this lesson, learned something from it, and please don't forget to press the subscribe and notify button. I also got the Facebook page related to this channel. You're welcome to join my adventure channel where I share photos and videos of various activities. Until we meet again in our next lesson, I wish you well and happy coding.